This is Food Chemistry Unit 3, Chapter 10, Lipids, Nature's Flavor Enhancers. A lipid is an organic compound. It's made of carbon. It's insoluble in water, does not dissolve in water, has a greasy feel. Like carbohydrates, it has carbon, oxygen, and hydrogen as part of its structure, and the lipid itself does not provide structure. The chemical structure of lipids, we have three types. Glycerides. There are two basic parts to glycerides. You have the glycerol molecule, which is right here. It has three, what's called an OH group. And then you have a fatty acid. And a fatty acid is a long chain of carbon. It can be anywhere from 4 to 24 carbons. Now, a monoglyceride is glycerol and one fatty acid chain. Diglyceride is a glycerol and two fatty acid chains. Triglyceride is a glycerol with three fatty acid chains. And I don't know if you picked up on the fact that those fatty acid chains are being added to that OH group. The H comes off and the fatty acid comes on. Phospholipids. This is a glycerol plus two fatty acids and then a phosphorus containing acid. Now the liquid in your cell is mainly water, right? Phospholipids will help move fats across it in the semi-permeable membrane. That's in your cell membrane, right? Now in foods, phospholipids keep foods like mayonnaise from separating. Sterols. These are complicated molecules derived from lipids. Cholesterol, get it? Cholesterol is the most common. You also have vitamin D and steroid hormones. Categorize lipids. You can categorize lipids based on molecular structure, based on how saturated the carbon chains are. So what does this saturated mean? Well, carbon can form single, right? It's these lines in between the carbons, connecting them together. Double, right here, that's called a double bond. And triple bonds. You could also have three of these lines between, right? When carbon forms a double bond, less hydrogen. If a fatty acid is saturated, the maximum amount of hydrogen can be attached to those carbons. There's no double bonds. So butyric acid in butter is saturated fatty acid. The stearic acid, which is in beef fat, is another saturated fatty acid. Both of these are from animal sources. So there's usually a lot of saturated fats from animal sources. Now, unsaturated fats. These have less than the maximum amount of hydrogen. If you have a double bond, there's less H's. Monounsaturated fats would have one double bond. This would be your olive oil, almonds, walnuts, and canola oil. Polyunsaturated fats have two or more double bonds. This would be your sunflower and corn oils. You can categorize lipids based on physical state. If they're solid at room temperature, this is your fat. This is mainly saturated fatty acids. If they're liquid at room temperature, this is your oils, mainly monounsaturated and polyunsaturated fatty acids. Margarine tends to be softer than butter because of that double bond. It's less saturated. Fats are usually from animal sources like butterfat from milk or lard from pigs. Your oils are often from plant sources like corn, soybean, peanut, canola, and olive oils. Hydrogenated vegetable oils, they add the hydrogen to unsaturated lipids. You can make some oils solids at room temperatures. Margarine can be made from 100% corn oil by this method. It has a longer shelf life, it has more stability, and has a lower cost of production. You can classify based on dietary sources. Milk fat, milk of cows, goats, and other animals, right? Vegetable butters, this is the seeds of tropical plants like cocoa butter. It's often used in cooking, baking, and even cosmetics. Oleic and linoleic acids, this is from corn, peanuts, sunflowers, olives, cotton seeds, sesame seeds. This is the largest group of triglycerides. Animal fats. Meats and poultry have lots of saturated fats. You can actually see it in the meat. This is the marbling. The more you see, the more flavor and more tender the meat, but also more fat. Marine oils. This is from fish. These oils are long chains of polyunsaturated fatty acids, but they often spoil or have odd flavors, and that's why you need to eat fresh fish within 24 hours. Functions of lipids in food preparation. Lipids transfer heat. So unlike water, which boils at 100 degrees Celsius and never becomes hotter, lipids will rise in temperature until the smoke point is reached. The lipid eventually breaks apart and smokes. Once the oil smokes, you want to discard it. It has undesirable flavors in the food if it's used. Deep frying. You need to reach a hot enough temperature without burning the surface. If the temperature is not hot enough, food will not cook all the way through and the oil just leaks into the food. If the temperature is too hot, only the outside burns to a crisp and the inside is raw. Lipids tenderize food. Fats will shorten long, tough strands in flour. Solid white fat for baking is called shortening. Now, the fat to flour ratio depends on what is being baked. If you want to bake biscuits, it's a 1:8 fat to flour ratio. So there's your biscuits. In pie crust, it's a 1:4 fat to flour ratio. In puff pastry, it's a 2:1 mixture of fat and flour, and it's layered between yeast dough. The dough is rolled into these thin rectangles, and this is for your flaky croissants or your danishes, right? Very delicate. Lipids provide aeration of food. Aeration means to add air into the batter. Saturated fats allow this to occur. It's usually for your cake batters. This is why you beat butter and sugar to aerate the butter. Lipids enhance the flavor of foods. This is why you add butter to rolls. Bacon fat is often added to soups. Olive oil is added to dressings. They act as emulsions. A water and a lipid mixture is what your basic emulsion is. This is your mayonnaise, butter, milk, and your bottles of salad dressing. The phospholipid lecithin is added to commercial products to keep them from separating, right? You see here is soy lecithin on the label. Lipids in the diet. Functions of lipids. They provide 9 calories or kilocalories of energy per gram of food. They take longer to digest. They make you feel full longer. They're a steady supply of energy between meals. They're stored as adipose tissue. This is usually under your skin. Fat surrounds vital organs for protection. Fats are needed for cell production. It's why a diet with 0 fat is not good. Fats help transport fat-soluble vitamins, A, D, E, and K. And we have a whole unit on vitamins where we'll talk about those. Essential fatty acids. These cannot be produced by the body. Linoleic and linolenic acids, these are the only 2 the body cannot make. Both are polyunsaturated and in most plant and fish oils. They're needed for growth and development in the body. If I could say this, linoleic is in corn, cottonseed, soybean oils. It's also in chicken. Linolenic is in canola, soybeans, walnuts, and fish. Omega-3 fatty acids. The name comes from the double bond at the 3rd carbon atom. These help lower triglyceride levels in the blood. They slow the growth of plaque in your arteries. Some sources of these omega-3s would be albacore tuna, salmon, lake trout, and sardines. So it's that 3rd carbon, if you count 1, 2, 3. Cholesterol. Cholesterol builds cell membranes. It produces hormones. It's rigid, so it helps solidify cell walls, but too much in the blood creates plaque, which are deposits on artery walls. Plaque reduces the elasticity of artery walls. Arteries, that's for your heart, right? This results in atherosclerosis or hardening of the arteries, which is dangerous. The heart then has to work harder, so your blood pressure climbs. This is the leading cause of heart attacks and strokes. So lipoproteins are clusters of lipid and protein molecules. They move cholesterol in the body. You have two types. You have this LDL, which is your low density lipoproteins. These carry cholesterol from the liver. This is known as your bad cholesterol. And then you have HDL, these high density lipoproteins. These find unneeded cholesterol and return it to the liver. This is your quote unquote good cholesterol. Now, LDL and HDL need to work together to keep your cholesterol in balance, right? Too much LDL clogs the arteries, so you need less than 100 milligrams per deciliter in your blood. High HDL protects against heart attacks, and it's better to have numbers greater than 40 milligrams per deciliter in your blood. And you can get these levels if you have a blood test. If you keep a balanced diet with exercise and healthy weight, you can manage your cholesterol, but again, for a lot of people, it's tough, so this is a health issue.